All right, section 5 of unit 6. Here we are finding the midpoint and the distance of a line, but we're doing this for diagonal lines. So it's a little different than what we were doing before, but very similar. I had said in section 4 that I want you to use these equations, and we see those right here. These ones for distance. I just highlight them here. For midpoint. These formulas where x and y are just referring to x and y points, and the 1 and the 2, x1, x2, are just from two different points. That'll make sense when we see the lines. And then those same things are used in this distance formula right here. And this is going to allow us to calculate the distance of a line when we can't just measure it directly. This is kind of like the Pythagorean theorem, where we have like a squared plus b squared equals c squared. But I don't know, you maybe remember that from previous years. Anyway, I have these all finished out. In here, just make sure that you know what you're asking or what's being asked of you. So just running through this quick, we're looking for the midpoint of the diagonal between 1, 1 and 4, 3. So I like to write out just my information here, 1, 1, 4, 3. Those are my 2 points. And then I label them as x1 and y1, x2, y2. Then when I plug them back into my midpoint equation, which I had up here, the midpoint formula, I can just solve for it. What I end up getting is 2.52, which is this point right here. Now the distance, again, we're looking for the distance of this line, this diagonal line right through here. So I use my points again, plug those points into the distance formula, and just as a little side note, when we're doing distance, make sure you're subtracting here. And it doesn't really matter if you have like x1 minus x2 or x2 minus x1, or with the y's, the same thing, because when we square those, you end up getting the same number. For example, if we had these flipped around, you would have a -3 squared here plus -2 squared. -3 squared is still 9, and -2 squared is still 4, so you're going to end up with the same answer. Now we're going to write these out quite a ways here. This goes out to 4 decimal places, and I just drop a unit on there of unit or units if I had room. Same thing as you go through in the second one, finding the midpoint and the length, but this time we're finding the length of this line and the midpoint of this. Still writing out my points, or the coordinate points, and then going through and calculating using those two formulas. Going down here, we're looking for this line. Was this a parallelogram? Something like that. This line that connects the two corners of the parallelograms, or two of the corners of the parallelogram. Same thing. Write out the coordinates for your midpoint that you want to find. You want to find the midpoint between -3, 5 and 1, 1. Plug them in. A little bit different here because we do have this negative in there, but that's okay. Just put it in exactly how you have it there. So we have -3 plus 1, which is going to give us -2. And we see that our midpoint is right here on our XY coordinate, which we have plotted. The distance, same thing as we did before. We're taking our points, we're plugging that information into this distance equation, and then solving. What you'll end up with, again, I took it out to 4 decimal places, is 5.6569, and that is this distance of that line. So just to kind of summarize, this stuff right here, midpoint formula, distance formula, this is something that you will want to have written down on the first page of your notes. So take some time right now, do that. That way you have it when we get to our exam. We're looking at an exam probably Tuesday of next week, maybe Thursday. We'll see. I think, well, after this, we'll be done with Unit 6. So we should be able to review on Monday and maybe take an exam on Tuesday. I have also posted Mr. Corellis' video of him going through this in much greater detail. This is just kind of the highlights. So anyway, I hope you guys are having a great day. I will see you on Monday.